Okay, we're going to talk about mutually exclusive and inclusive events today. So mutually exclusive means that whatever you're doing, you don't have any outcomes in common. So think about flipping a coin and rolling a dice. They don't share any outcomes. Or if you flip a coin, getting a head and a tail at the same time. Can't happen. So they're just events that will never occur at the same time. There's a dice example, rolling a 2 and a 3 on a dice at the same time. So our probability mutually exclusive events, the formula is we have our probability of A or B, and we just split that into probability of A, and we add the probability of B. So we're going to look at an example. We have two dice that we're rolling, and we want to know what's the probability that I roll a sum of 6 or a sum of 11. Well, we can't have a sum of 6 and a sum of 11 at the same time, so we know that it's mutually exclusive. So using our equation, we have the probability of our sum of 6 or 11 can be split into our two separate sums. And then if you think about rolling two dice, here's the ways you could add up to 6. 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1. So there's 5 different options there. And then to add to 11, you would have 5 and 6 or 6 and 5. So we know the numerators of our two probabilities, and then we have to think how many total options would there be. And we get 36 on our denominator. That's the total number of sums that we get. And we get that by taking the 6 options on our first dice times the 6 options on our second dice. Okay, so 6 times 6 gives us that 36. So our probability of sum of 6 or 11 comes out to be 7 over 36. I want you guys to find this probability. We have a jar that has 6 marbles. There are 4 green marbles, and they have numbers 1 through 4 on them. And there's 2 yellow marbles labeled 5 and 6. So I want you to find the probability of yellow or a number less than 3. The other type of probability we're going to talk about is inclusive events. This means that we can share an outcome. The events can occur at the same time. So we still have probability of A or B. We split it up, probability of A plus probability of B, but then we have to subtract the probability of A and B occurring at the same time. So go back to our marble example. We had 6 total marbles, 4 greens numbered 1 to 4, and 2 yellows labeled 5 to 6. We want to find the probability that we have a green marble or a multiple of 2. Well, to decide that this is inclusive, you have to look at your 4 green marbles. Are there any multiples of 2? Well, multiples of 2 would be 2 and 4, and there are. So they overlap there. So we have to use this inclusive formula. So we split it into probability of green plus the probability of being a multiple of 2 minus the probability that it's green and a multiple of 2. We have to subtract this out because these events right here have been counted 2 times. So we have to subtract out one of those times. So probability of green would be 4 out of 6. Multiples of 2 would be 2, 4, and 6, which is 3 out of 6. And then green and a multiple of 2, look at this line, we would have 2 and 4 in there. So we subtract 2, 6. 4 plus 3 gives us 7, minus 2 is a total of 5, 6, or a probability of 5, 6. Please find the probability of a yellow marble or a number greater than 3.